Hi all, this is the MakeHaven magic video for the vertical metal bandsaw. So in the wood shop we also have vertical bandsaws for wood, and in the metal shop we also have a horizontal bandsaw for slightly different purposes. So what makes this one special compared to the wood ones is that it spins a lot slower. When you're cutting wood, you might be cutting at 3,000 feet per minute. Just to say 3,000 feet of this blade goes by a certain point per minute. When you're cutting metal or steel, you might be like 100 feet per minute. So it's much, much slower. And then a horizontal bandsaw is good for making straight cuts through long stock. With the vertical one, there's a little more maneuverability. You're using it by hand, same as a wood bandsaw, so you can do curved cuts, you can resaw effectively, you can do other things that you couldn't do with a horizontal bandsaw. So we'll go over basically what a bandsaw is. The reason it's called that is because the blade is one big band, so it goes all the way around. There are teeth on it that are cutting downward, so it spins in this direction. Pretty hard to turn right now. And cuts metal, and then it drops out the bottom. There's not a whole lot else going on. One thing about the metal cutting bandsaw is you can change the speed on it using this knob. So you can get it to go faster for aluminum versus slower for steel. And some of the other things that we're looking at on here are, this is an e-stop. We have also an e-stop on the control box right here. So in general, we can leave this not depressed, but if there's an emergency, this one's really easy to whack. So feel free to hit that one to turn it off. This controls the bandsaw, so this is on and off. This is the welder's lamp. So this is the welding unit. Sometimes if you're in a professional environment, if a blade broke, you would want to re-weld it. Or the blade would come in one long strip, and when you wanted a new one, you would weld it up yourself. It's a bit of an art, and I think for us it's just easier to buy the blades of the right size, so we're not going to be using this. However, just for your own edification, the way it would work is you would use this to cut the blade to the right length. You would grind off the ends so that they're nice and clean and straight, put them in here, clamp, set the pressure, weld it, and you would see it glow cherry red hot as it welds together and squeezes them together, and then you would anneal it. And so once you've heated metal to that temperature, it's very brittle, it's hardened, and annealing softens it. So you pulse the electricity a bunch of times, and that softens the crystal structure of the metal, and that makes it more flexible again. And then you might grind down the weld if you need to. But again, we're not really using that here. This also has air built in, so you can turn on the air valve on the back, and then there will just be air blasting right on the blade to help clear the chips out. So you can see your cut line, and so you can help prevent the teeth from getting clogged up. There's a tension knob up on the top here, and with the tension knob, you can increase and decrease the tension. We're just going to leave it tension, so it should be good. But you're just feeling for a good firm blade. If it feels like it's really flexible, or it feels like it's totally rock hard, then it might be a good idea to adjust the tension. And then the blade goes all the way down through the bottom. There's also a brush to clean off the wheel, because on the bottom the chips might still be on the blade, and this would clean those off the rubber wheel. The blades are, the one we have on now is a general purpose blade. If you were cutting something that falls outside of general purpose, then you might want to put it on your own blade, and just speak to a facilitator about that. But for buying purposes, the blade is 140 inches long. So if you wanted to buy one, that's what you'd be looking to buy. So some safety things, you want absolutely nothing dangling, no sleeves, no necklaces, long hair, that isn't tied up, it could get caught in this blade because it'll just take it. And even after you hit off or the e-stop, it's going to keep spinning for a while. So you really want to make sure that there are no body parts near there. For some reason, you might be tempted to put your hand under here for some reason, don't do that. The blade is exposed down there, so you're not going to do that. Another danger is the blade can break on a bandsaw, as I mentioned. If it does that, it tends to shoot out in that direction. So that's why we pointed it at the wall, but bear that in mind. Just, in case you had some thought to remove your glasses, absolutely don't ever in the metal shop or wood shop. That's just one reason. They could bounce back off the wall and come at you. If it didn't have a wall there, it would go for a while. Another concern is when you're cutting metal, it can get hot. So be mindful of that. You're not wearing gloves on most any tool where your finger is getting anywhere close to a blade, because the chance of it grabbing that glove and pulling it in and just destroying your whole hand that's much worse than you getting a little cut. So that's why we don't wear gloves. In terms of some of the other things on here, this is the blade guard. You raise this up and down, so it's about 1/4 inch above your workpiece. This is a light, the air, as I mentioned. There are wear plates right here, so that helps keep the blade aligned so that it isn't going side to side as you're pushing and turning. As I mentioned, you can do curved cuts on a bandsaw. This band is about 3/4 of an inch wide, and that means the general rule of thumb is that you can make a curved cut with a radius about 3 times as thick as your bandsaw blade. So in this case, if it's 3/4 of an inch, you can go up to 9/4 of an inch in radius. So that would be maximum circle, or 2 1/4 inches. If you wanted to make tighter cuts, it might be a good idea to get a different blade. Okay, so this bandsaw can be used for kinds of metal. The softest, as soft a metal as you want. The hardest you can do is like a mild steel, maybe a carbon steel, but definitely nothing hardened. For that, you want carbide teeth. That would just crush the teeth here. It wouldn't do anything good for you. And as I said, for harder materials, you want a slower speed. So you crank this counterclockwise to go slower, and then clockwise to go faster. You only change this, and it says this on this note here, to only change the speed when the blade is running. So when it's sitting still, you don't try to turn this. It won't do anything good. So for aluminum, you crank this all the way to the max in terms of speed, and steel all the way to the bottom, and then for something in between, say brass, you would go somewhere in between. The goal when you're cutting with most things in the metal shop that have teeth is to get nice chips. So that means you're not trying to make powder, you're not trying to make chips that are glued from how much heat. You're trying to make nice little curls that are maybe warm to the touch, but not, if they're scalding, then there's too much heat. You need to not push so hard. You need to change something. So the factors that you can control are how hard you're pushing, the type of blade, the type of material, the speed, and you're going for nice, small, warm curls. And that's the goal. One other thing to note about materials is you need to engage at least 2, preferably at least 3 teeth at a time. So cutting something really thin, like as thin as this card, would only engage probably 1 tooth. And so it would just be shattering and bashing away. So that is no good. So you want to be engaging more teeth. If you want to cut something really thin, then you need to get a blade with more teeth per inch, or consider a different tool. If it's that thin, you could probably just use hand snips. As another point of note, in the band shop, you may know that the wood shop, the bandsaw has much bigger teeth and bigger gullets. So as your material gets harder, you use smaller teeth, more of them, with smaller gullets. The gullet is the space in between each tooth, and that just allows for it to take a smaller bite at a time. If you tried to put metal through the woodworking blade, it would just not be possible. It wouldn't be strong enough, it would break the teeth. So that's something else to bear in mind. The last thing I'll mention about bandsaw blades, there's a lot to talk about, but the teeth have set. which means that they go back and forth. Each little tooth is facing a different direction, so that the kerf, the width of the cut, is actually a little bit wider than the blade. So that after you cut, the back of your blade can go through that cut. It isn't pinching it. As you cut, it can heat up and expand a little bit, and so it wants that cut to be just a little bit wider. It also makes it easier to make curved cuts. When we do like a quick inspection, we just want to again check the tension. We want to do a quick look to see if it looks like someone's destroyed this with a piece of hardened steel and there are a whole bunch of teeth that are flattened. So if you can't spin it, which I can't right now, then you can just give it a once over. If someone were to push hardened steel onto it, it would flatten most of the teeth. An easy check, obviously when the tool is off, is to take your fingers, and if you want to be able to pull down easily, but if you try to go up, the teeth should bite your finger. If you can slide your teeth up as well, then the teeth aren't very sharp anymore. So here it's biting, so I know that it isn't, so that the teeth are still sharp. Okay, so those are most of the things. Another thing here is a push stick. If you're doing something where your fingers are going to get close, use the push stick. Let's say the blade was taking a while to slow down and you wanted to get your piece, you just grab the push stick, and push that part away so that you aren't tempted to put your fingers near the blade while it's still spinning. Another note about that is when you're cutting, let's say you're cutting an whole piece all the way through, you could start by pushing, and then when you get about halfway, you can transition to pulling. So you don't need to get really close with your fingers. Another note is there are slots here for miter gauges. So you could grab a miter gauge and cross-cut something if that was helpful for you. So with that, we're going to try cutting something now. So I'm going to close this up, and one other thing that I forgot to mention was making relief cuts. So let's say you were making a curved cut in a piece of metal. Say you wanted to cut like this. What you would want to do is cut relief cuts like this. And so you cut the relief cuts first. You cut in, and then as you're cutting, these little chunks of metal would fall out. And so that would make it a lot easier to make those turns. That would also mean that you could back out more easily without having to pull the blade all the way back through, because you've already dropped out those little pieces of metal. So relief cuts are an important technique for making curved cuts. For this cut, we're just going to cut this little protrusion off the piece. The feed pressure is a pretty important part here. So you want to not push so hard that the blade can't handle it, but you want to push hard enough to engage the teeth. So I'm going to swipe my badge and turn on the tool here, and then I'm going to turn the air on the back, and the regulator should be preset to the right pressure, so that should be fine. That. And now I'm going to turn this little light on here, click it a few times to get a little more. The blade guard is set to about a half-quarter inch above the workpiece. You can just, there's a knob on the side to loosen, to raise and lower this. I'm going to tighten that right there. And again, push sticks there. We're just going to be cutting off this little piece. So I'm going to turn it on and we'll hear where the speed is at. We can also feel it. So this is on. And it's already up to full speed. If you wanted it slower, you can turn it down. But we want it at full speed for aluminum. Aluminum can cut up to 1,000 feet per minute. This is around 500, I think is the max. And we are just going to push through with a good firm stance. So before there was some chattering, and I think I was just overfeeding the material. The bandsaw is actually pretty slow. If this could go about twice as fast, then you could feed a bunch faster. But when when you're going up to 500 feet per minute, you just need to feed accordingly. So hopefully now this is all the way up at full speed, this should sound a little better, pushing a little less hard. So something else that I didn't mention was that this table can tilt in both directions. So underneath here, you can tilt the table by loosening these bolts. You can tilt this way, and then by loosening the bolts on the back, you can tilt the table side to side. So that's another useful feature of this saw that the horizontal bandsaw doesn't have. When you're done using this tool, you just want to grab the vacuum and vacuum up. Make sure to turn the air off over here, and the light will turn off when you push that button.